Welcome back to the Introduction to Materials. In this video, our objective is to take this material that you currently see applied to our floor, this nice rocky material, and we're going to embellish it a bit and add a few different things to it. We're going to take that normal map and make it a lot more visually interesting. We're going to add a little bit of specularity to it and put some shine on our rocks.
Like you said, it's a nice material. But we can do so much with it to make it look more realistic.
Yeah, and we can do even more than what we're going to show, but we're going to take this a step at a time.
That's right.
And however, before we actually get in and start working with this material, I want to take a second and start talking to you about the various material channels that are available to you on your material node inside the material editor. Now, let me begin just by opening up my generic browser. We'll take our Zach Rocks material and double-click on that.
I'm telling you, you named it that just so you could continue saying Zach Rocks throughout this entire series.
It's true.
Understand.
But it is a good description.
So there you go. You can see all of the different channels available to you on your material node right there. Things such as diffuse, emissive, specular power, etc., etc. Now, if you happen to be coming over from a 3D application, you've got it made.
That's right.
Most everything that you see here is going to make sense. And to be honest with you, you're probably ready to jump in and start building things right now. Start experimenting with those material expressions found over in the material expression list. But if you are new to the world of creating materials and working with channels, well, we need to spend a minute and talk about what these things provide.
That's right. First off, channels in general, what are they? They are ways for you to affect a specific aspect of a material using a material expression, or 9.
That's right, or 9. I like that.
In general, you're going to be creating a very large network of expressions and taking that network, tapering it down to a single material, which will plug into one of these channels. Each one of these channels can only have one incoming input. Only one. You can't take like the normal map and also plug it into diffuse.
Nope, it'll replace it.
That's right, because it ends up replacing it. So keep that sort of thing in mind. Now, what channels do you have available to you, and what does each one of them actually do to your material? Well, the very first one you have, the most common one that you'll be using, is your diffuse channel. And that's a really interesting way to say color. Because really that's all it's doing. Now, you can assign, the reason they don't just say color is because you can assign color in a lot of different ways. I mean, your emissive channel will change the color of your material, so will specular to some degree. Your transmission mask and color can both be used to tweak out your color. There's a lot of different ways to...
You can just think of diffuse as the general color you're going to see from the material.
That's exactly right. It is the base color. Now, underneath this, we have emissive. This is the ability for this material to appear to be emitting light. That is what that is all about. Now, if we were to take, say, I don't know. You'll notice in the last video I was using a vector 3 constant for demonstration purposes only. I'm not saying you should do this or make a habit of it, but just for demonstration, I'm going to bring in a vector parameter. And that's simply because a vector parameter node over in its properties has the really wicked sick color picker. And just because I'm lazy and I don't want to try to think of an RGB value, we're going to pick some cool shade of orange. I'm not one of those guys who can be like, I need orange. That means I need exactly these RGB values. I've never been good at that. I'm going to take my overall color and plug it into emissive. Boom. And now you'll notice we suddenly have no shadows. Our material appears to be glowing. Now, it's not glowing that brightly. Not yet.
Not yet.
Not yet. Now, we could jump back into our little vector parameter here, and we could take our values and push them beyond 1. So you can actually, let's just double everything. We'll multiply everything by 2. So 1 will become 2. 0.54178 is going to become 1, because I'm rounding, because I'm not that good at multiplication. And this will become 0.0012, or I think it was something like that. So we get essentially the same color, only a whole lot brighter. And you'll notice, if you look really closely, we start to get this glowing halo around our object. It's glowing so bright that we're starting to get a bloom effect. And that bloom is there by default. It is very cool. You know, it's one of those trendy things you can make use of, especially for things like glowing light switches or parts on your character that glow like the movie Tron. I think that was the first thing I did when I first got my hands on the material editor, was I made a cool Tron material. But that's what it's there for. It is there to simulate the emission of light. And when I say simulated, I mean that it's not really light. If I apply this...
Right, you're not going to drop this into a level and it's going to be illuminating the things around it.
Well, here, let's check this out. If I go ahead and apply this, and let's close this out for just a moment. One, my floor looks ridiculous, but you don't notice any light creeping up on the walls. If I wanted some sort of yellow light to look like it was coming up from the floor, I would need to actually place some lights along the floor to simulate that effect. So just keep in mind, this is like the simulation of light emission. It's not really emitting anything. Okay, so with that, let's go back into our material editor. Let's get this all open back up. And before I go any further, I want to bring up sort of an advanced topic in terms of these channels, because you might be thinking to yourself, well, what good is it being able to just assign a single color to my emissive channel and just make the whole thing glow? Naturally, in most cases, you're going to want only part of something to glow. Maybe, for a piece of BSP, maybe a stripe that's going to go along the wall. So, you have students who are in battle school and you need to lead them to their classroom.
I've got it, Zach.
Yeah.
As you're working your way through making a nicer rock texture, how about we make all the little crevices between the rocks actually look like they're glowing?
Oh, I'd love to, but not right now.
No, not right now. But how about we work towards that?
That sounds great.
So we'll take these videos a little bit further. We'll make this look snazzy.
Okay, but that'll be in a later video.
Of course, but I'm just taking what you're suggesting right now, and let's apply it to this as we work our way through the material editor.
Absolutely. It's a great idea, and we will be doing that. So just wanted to say this, though. You will, in general, be applying some sort of a texture to each one of these channels. And that texture may not necessarily just control the color. That texture may serve as a quote-unquote mask, and you're going to hear that term a lot as you get into materials and start working with them. And a mask is simply a way to control where an effect is happening.
Or how much of the effect is getting through.
Or how much of the effect is getting through. For example, I could have a texture, and I'm reaching here, and you got to kind of conceptualize in your head with me, so bear with me. We could have a texture that looked like a checkerboard, black and white checkers, okay? We could multiply this yellow color by that checkerboard. What would that actually do? Now, I'm not going to do it here because we don't have a checkerboard texture, and I'm not going to create one just for the video.
It seems to me like every place there's black, that's a value of 0, as we've already seen. So if you were to multiply the yellow RGB color by an RGB color of 0, 0, 0, you would end up with a result of 0.
That's
right.
right.
Means that particular area would not be emissive.
You'd have yellow glowing checkers and then areas that weren't glowing.
That's right.
That would be your overall result. Now, why am I telling you this? Because in general, when you're creating materials for objects, in most cases, you're not creating BSP materials. You're creating materials for objects such as static meshes or characters. Those are objects that are going to have UV texture coordinates that have been created for them inside of an external 3D package. This is not something that you will be doing inside of Unreal Ed, just to drive that home. And it's not something that we're going to be covering in this video series. So remember that. But you will simply use a mask as a way to control where an effect is happening along the surface of an object.
And we'll actually do that with this sphere.
Yeah. So just a little bit later, we'll actually make the crevices glow. If you're completely confused, just put everything on hold, and we're going to make it all clear later on. I just didn't want anybody to get the wrong idea thinking that all you can do with these is plug in some color. I'm just using the plugging in of colors as a way to kind of show you what each channel is doing. So enough with that. Let's move right on. Next, we have our specular area, and we're actually going to be using this one inside the video. But what this does is this allows you to control how shiny an object happens to be.
Your hotspot.
Yeah, exactly. If nothing is plugged into this, we have no hotspot. We have no shininess value. What I'm going to do is take my little vector parameter, and I'm going to keep saying this several times in the video. I don't necessarily recommend you use a vector parameter.
It has a specific use, which we'll get into way later on.
Right. Don't use it just because it has a color chooser. I'm just doing that for the demonstration.
He's just doing that because it has a color chooser.
Right, but don't make a habit of it because it has a little bit of overhead. A much more efficient workaround would be we could bring, and I'll go ahead and do it. We could bring in a vector 3 constant. And this would be the right node to use. So you come over here to your vector parameter. You could choose, I don't know, let's just say some shade of green. And then if we expand out our default value, we get those RGB values, and we can plug those into our vector. That would be a much more efficient way to go about it. Now what I'm going to do is I'm going to delete this out. Because we are just doing a demonstration, I'm going to keep using this guy. So just keep that in mind. I'm going to set this over to a value of white for the time being, and we'll plug it into our specular channel.
Ooh.
And we get fancy shininess. We don't,
almost wet.
Yeah, we don't. And why do I say it's fancy shininess? Well, for just a moment, I'm going to disconnect our normal channel. So holding down the Alt key, I'm going to left click here on this input, and boom. Now we have a very typical kind of hotspot. And really what this ends up looking like is a painted piece of plastic.
It's like one of those stress balls.
Yeah. Yeah,
that you can rotate around in your hand.
Yeah, that really does kind of look like that with a really cool lacquered paint job on it.
Yeah, exactly.
But that normal channel was adding some visual depth, and the cool thing is that specular channel will be driven by that normal. So when we plug this back in, the three-dimensional nature of that bump, that tactile texture that's been applied, also receives that shiny information. So now the shininess value, that hotspot, is scattered across these multiple rocks. So a very cool thing. And really, all this is doing is controlling how much that shininess is there, and it's controlling the color of that shininess. For example, excuse me, I could set this to, I don't know, some bright shade of obnoxious green. And you wouldn't normally want to do this. In fact, you probably would.
Because it looks pretty ugly.
Yeah, you wouldn't ever want to do this. Why? Because we have white light hitting this, and for some reason it has a green hotspot, and that just looks completely out of place. Now, with certain types of metals, like let's say you have blue metal, you might want to take your hotspot and tint it slightly toward blue.
Right.
Because when light comes back off of metal, it's going to pick up some of that color. But you're going to have to take a look at various surfaces and study how they behave with light to really understand that. That is not the purpose of this video. All I'm just showing you is that our specular channel controls our amount of specularity, and it controls the color. I've shown you the color, but let me set this over to white for just a second. And you'll see everything goes back to white. If I start setting this to darker values, which in the end essentially just boils down to shades of gray, so I can pull this down to 50% gray, we are in effect reducing the amount of specularity we have. In fact, it looks like we've kind of nullified it, but if we hold down Alt and switch off specular, you'll notice that there is a change that takes place. It's subtle, but it's there. And I want you to keep in mind, if you're completely new to this, the power of subtlety. Sometimes the greatest difference that will push your material from something that looks good into something that looks realistic, in a lot of cases, it's just going to be a subtle tweak. So don't ever think that, well, I need my rocks to be shiny, so let's go ahead and go for a super white hotspot. In a lot of cases, you don't need that. In fact, a rock, if it has any shininess at all, because you don't necessarily want it to look like chalk, it's just going to have a little bit. In fact, this might be a little too shiny because our rocks look like they've been waxed, like a waxed concrete floor.
And, of course, we need to get in there and make sure that in the crevices, all of those white spot areas are gone.
Exactly. We're actually running into a bit of a problem with our specularity right now because our moss is shiny too. And that's where we get back into the topic of masks, which I broached earlier. Now, moving down from here, we have specular power. And to really drive that home and make it make sense, I'm going to do a couple of things. First, we're going to take our specular color. I'm going to set it back out to white. Then I'm going to hold down the Alt key and I'm going to left-click on the normal connection so that we break that again. And what I want you to pay attention to is the size of our hotspot here on our surface. In fact, just to really make this make a whole lot of sense, I'm going to take my vector parameter and temporarily, because I'm interested in speed, I'm going to make a copy of it. And we're going to set this to any color you like. I like red, one of those red guys. And I will plug this into the diffuse channel. So what I want is a very simple material that is just red with a hotspot. Specular power is essentially the size of your hotspot, and this is looking for a single numeric value, not a vector 3 like we're plugging in here, or a vector 4 in this case, but we're just using the RGB. Let's go ahead and create a vector 1, which is just considered to be a constant. Now we can
just a constant. Not
right. I mean,
let's drop that term vector altogether.
Yeah,
and let's
okay.
just use a constant.
You're absolutely right. It's just a constant. I'm just getting overzealous with my use of vectors. And why? Because psychologically, I see 4, 3, 2, and my brain says, well, there must be a 1.
No, we'll use a constant.
There's not. So forgive me on that one. You can rib me on the forums about that later. But I'm just going to drag a constant in here, and we're going to set this to a value like, I don't know, something like 2. And I'm going to connect this into our specular power. And you'll notice the size of our hotspot changes. If you set this to 0, something kind of scary happens. So you don't want 0. 0 is clearly bad. So let's set this to 1, and we get this super bright, crazy hotspot. And as you push this higher and higher, your hotspot is going to get tighter and tighter. So there's a value of 20, which I think is pretty close to the default value.
Almost.
Not quite, but it's pretty close. It's going to have to be something like 15 or whatnot. But we can just really crank this. We could say maybe 300, and we get this really tiny hotspot. If specular power is too much for you to remember, or if you can't make a mental connection with that, think of this like glossiness. You've got your shininess, but now you can also control the glossiness too, because the glossier something is, the tighter that highlight's going to be. So let's go ahead and disconnect that. We don't necessarily need it. Next to this, we have opacity. This is the now this is Logan's term. I can't take any credit for this. I first heard it come out of Logan's mouth, but I love it. This is the see-throughness of our material.
Yeah, that's a great term.
This is how well you can see through it. And the funny thing about this is it's going to be based on a 0 to 1 value.
How opaque it is.
Yeah. Okay. Did I say how transparent?
Yeah.
Okay. But they're interchangeable.
It is.
It's how solid it appears. Now, the funny thing about this is it's based on a 0 to 1 value, with 0 being completely transparent and white being completely opaque, and the varying levels of gray in between being various levels of opacity. So what I'm going to do is I'm going to take my constant here, and we're going to set it to 0.5, which is going to be halfway transparent or halfway opaque, depending on whether or not you're an optimist or a pessimist. And I'm going to plug this over into my opacity channel, and you'll be amazed and excited to note that absolutely nothing happens.
That's right.
And the reason nothing happens is because our blend mode on our main material node is set to blend opaque. So no matter what we plug into here, this is always going to be opaque. If we want to make use of this, we need to use translucent, which, as you can see, starts to give us a see-through. You can kind of start to see that grid through there. But you'll notice we also lost our lighting. Or I believe we can use additive as well. But the big one you'd really be looking for there is translucent. Now, the reason you're going to use that is because when you're using the translucent blend mode, you can start using these various levels. So if I set this to 1, we get completely opaque. If I set it to 0, we get completely transparent. I can set it to like 0.01, and you can just barely see it. In fact, on the video, it might not even show up at all. So let's say 0.03 or 0.05, and you just really start to bring that up slowly but surely. But do keep in mind that you don't have that default lighting anymore. So you would have to fake that. Now, I'm not going to go into how to do that. That's a little bit advanced for this video series, but I will point you in the right direction. You'd be doing that with either a cube map of some lighting, and in general, in your level, if it is a static object, light maps that are generated when you build lighting will show up. So all that to say, if you have a translucent object that is static, it will still have some sort of lighting on it if it's not moving at all. Remember, the key static there. Mm-hmm. If it is a dynamic object, it's going to end up looking like this, where it's kind of flat and loses its lighting. So food for thought for later on down the road. So that's a quick look at opacity. Opacity mask, I am not going to actively demonstrate. Let me set back over to opaque. I'm not going to actively demonstrate this right now in this material. I'm just going to tell you what it does. It's very similar to opacity, except that it is designed to receive a texture. Now, over here inside of opacity, I was allowed to put a solid color in there if I needed to, but I very well could have made a texture. I could have had a texture that was a gradient between black and white. And let's say it goes from top to bottom, black on the bottom, white on top, and a gradient in between. I would have had transparent on the bottom, opaque at the top, and the whole surface would seem to fade away as you went from the top down. You can't do that with opacity mask. Opacity mask is a binary approach to opacity. You can either see something or you can't see something. There are no various shades of gray in between. You can think of it as a black and white approach. Now, when you apply a texture into this, again, nothing will happen unless you come down to your blend mode and set it over to blend masked. Suddenly, you'll have sections disappear based on your texture. A really good example would be if we go back to what we mentioned earlier with the black and white checkerboard. The black checkers would disappear. So you'd be able to see through the object wherever the black checkers were, but the white checkers would still be visible. Now, the thing about doing that is you have an opacity mask clip value. Even if you plugged a grayscale sort of texture in here, like maybe that gradient we discussed earlier, this is where you would control where that clip takes place. Because now, even if you plug like a gradient into your opacity mask, your end result is going to be binary. You either see it or you don't. And this value, this opacity mask value, allows you to control at what value you start to lose your opacity. So at this point, 0.33 and below is going to clip out to transparent. So just keep that in mind, and you can adjust that if you needed to. Now, let's see, is there anything else as far as opacity mask is concerned? I feel like there was something. Oh, yeah, if you have some, if you end up creating something that is masked or even transparent for that matter, it might not be a bad idea to check two-sided so that you can see it from the opposite side, because if you don't, you won't be able to see through it. And we'll talk more about that perhaps a little bit later in a future material. Now, let's move on down from here. We have distortion, and this is where stuff starts to get kind of cool, and I don't know if there... Well, okay, yeah, I can probably show off distortion, but it's going to take a little bit of patience from you guys. What I'm going to do is bring in a new constant, not a vector one, just a constant, and we'll plug this into opacity. And let's set this over to, let's say, translucent, so the whole thing seems to disappear.
Might want to stay on top of the hotkeys, just letting them know what you're hitting.
Oh, did I hit something? I do that so often.
That's okay.
Okay, what I meant to... Here,
when you brought in the constant.
When I brought in the constant, I'm so sorry. Thanks for the save on that one. If I hold down the 1 key on the keyboard and left click, we get a constant. So no, I'm not a magician. You can do that yourself. Just hold down the 1 key. And if you need a vector 2 constant, it would be holding down the 2 key. 3 would be 3, and so on and so forth. So let's plug this into opacity. I'm so sorry about that.
Oh, that's all good.
So this thing immediately goes invisible because we set our blend mode over to translucent. Now, I'm going to give you a little known secret, or maybe you already knew it. I don't know. These bump maps that Epic has created, in general, they have an alpha map inside of them that is a black and white version of this. It's kind of like an old school bump map. And I'm going to plug this temporarily into the distortion channel. And, okay, we don't see much, but you can kind of see a little bit of distortion here. Now, you don't have to use black and white. In fact, it's encouraged for you to use R and G values. And hang on, let me tell you what it's doing, and then maybe it'll make a little more sense as to why. There you go. Now, there's some cool distortion taking place. Let me try just plugging in the R, G, and B. Okay. And what you see there is almost like a refraction. And that's essentially what it is. It's a simulation of refraction. Now, technically what's happening is the material is reading the pixels that are behind the surface. It is pasting those onto the surface, and then it's pushing them around a little bit. And how does it go about pushing those around? Well, it actually does it in 3D space. Or I think technically it's 2D, but it uses color information. It's going to use red pixels or values of red to move along the x-axis and values of green to move along the y-axis. So it's just taking those pixels and it's perturbing them and giving you the simulation that you have refraction. This is really useful if you need like a heat shimmer effect, or maybe you have that sort of cloaking device effect like the movie The Predator, where something kind of starts to disappear, or any sort of distortion effect like that. That is what this channel is all about. Let's go ahead and make that disappear. We'll kill out opacity, and I'm going to set my blend mode back to opaque to get us back to our basic red material. In fact, I don't even want the red material anymore. I'm going to bring back my texture. Now notice I dragged over to the edge, and we start sliding around a little bit. That can be really useful if you need to truck across the scene. Like if I need to plug this all the way in over here, we can just fly over. Let's make a little bit of room. And again, just as a refresher, in case you've already forgotten, select a node and hold down Control and left mouse drag to move it around. I'm going to take my RGB channel and plug that back into diffuse so that everything's looking good. And just for the fun of it, let's take our normal map and plug that back into normal, like so. So everything's looking okay. For now, I'm going to disconnect my specular to simplify things up a little bit. Our next channel is transmission mask, and I'm actually going to talk about this at the same time as transmission color. If you are completely new to the world of 3D and video games and everything, then this might be just a little bit longer of an explanation. If you have some experience with 3D applications, this is where you simulate subsurface scattering. Ooh, now that's cool because that's a big high-end rendering feature. If you have no idea what subsurface scattering is, what I want you to do is to get a really bright flashlight, like one of those little tiny pen lights. I want you to put it up your nose. Okay, no, you don't really do that. I'm kidding. But if you do take like a really bright light and
put it up to your thumb,
or the little piece of flesh you have between your thumb and your index finger, when light tries to pass through flesh or any sort of translucent material, it's going to hit all the little tiny particles and it's going to be scattered around. That's why when really bright lights hit somebody from behind, you can see light coming through their ear or sometimes passing through their nose because it's a thinner area. Or sometimes even if you put a really bright light, put your hand over it, you can see the bones of your fingers inside, your fingers. It's really cool. That is because light is not just going right through that surface like it would glass. It's hitting all the little tiny particles and scattering in all these different directions. Now, using the transmission mask and transmission color, you can actually simulate that effect on your own objects, like your own characters, or maybe you have a static mesh of a candle. You could do the same thing. It's really popular in Unreal Engine 3 characters to have maybe the ears have a little bit of subsurface scattering in them, so when a bright light comes in from behind, you see some red tint coming through, like the light is passing through the blood in their ear. And here's how these work. First, let me start off with transmission color, even though I know it's the underside, what's the bottom one, but that's where we'll begin. This is where you determine what color the light's going to be as it passes through. Like if you try to shine light through your hand, it's going to come out red because you have a lot of blood under your skin. And so it's going to have a red tinge when it eventually comes out. This is where you would establish that color. So I could take my little floating vector parameter here, and let's give this a red tone. I'll make a darker red, though really it doesn't matter. It's the color itself that's important. And nothing happens, and that is because we need to use our transmission mask. And remember, what is a mask? We mentioned it earlier in this video. It is a way to control where an effect is taking place on a surface and to what extent it's taking place. And in general, whenever you see the word mask, you can bet your bottom dollar that you're really just looking for a black and white texture. Now what we're going to do to save a little bit of time and effort is I'm going to create another single constant. So hold down the 1 key and left click again to make that magically appear. And I'm going to plug that into the transmission mask. And as I start to bring this value up, so let's select our little constant and I'll go over here into its R value. We'll push this to 0.5. As I start to bring this up, you might notice a subtle amount of red light start to appear as if it's coming through this. Now, maybe this doesn't show up too well in the video, so let's push this up a little more. I'll say all the way to 1, and boom, it looks like the underside of the rocks are glowing a little bit. To be more precise, the shadowed areas of the rocks are starting to glow. So it's giving the effect that light is hitting the rock, passing through it, and then illuminating the underside because it's scattered throughout. So now the rocks almost look like they're actually kind of clear, and they're made of some sort of maybe red stone or red ruby, but they've got some sort of weird dusty coating on them. It's hard to say, but it's an interesting effect. As you move around here to the completely shadowed area, you still pick up some of that reddish hue. So that's essentially how that works. Now, on a character, what you would see is a special map, a special texture that plugged into the transmission mask where white areas designated where you wanted this transmission to take place and darker areas showed where you didn't want it. You don't necessarily want your character's entire head to look like it's made of wax, so that light just passes through it. Whenever a flashlight comes up behind your character's head, you don't want to see light come through. But maybe in the ears.
Right.
So you would take the texture and paint their ears a little lighter, and maybe the head would be completely black, that sort of thing. The nose would also be a little bit lighter, so light's starting to come through there. But that's how this works. Transmission color controls what color the light is going to be as it scatters through the surface. Transmission mask controls where you want that scatter to take effect. So enough of that. Let's go ahead and close that out. We'll delete that out, and we'll delete this out as well. Now down from here we have normal, which in essence we've already covered, but I'll give you a little bit more of a description of it. A normal map is a special texture that has surface depth information, and it works in all 3 axes. You'll notice it. I can't really open this up and make it bigger, but what I can do is we can open up our generic browser, and I can double-click on this guy, and you can take a closer look at this normal map. You'll notice that you have some red here along some of the top areas. It actually gives it a nice 3-dimensional look. It almost looks like a red light was shined from the top, that a green light was kind of shined from the side, or do I have it wrong? No, I think I'm right. And then a blue light was shined from dead on. It's kind of hard to say because we have such round areas, so it's a little tricky to see where the light's coming from. But essentially, you can think of this as if light was shined from all 3 of the primary axes, from X, from Y, and from Z. And from the resultant color information, you get a clear picture of where crevices, where changes in elevation take place along the surface. That is how a normal map works. Now, if you are already familiar with old school bump mapping, which was a grayscale version of this where darker areas would be indentions and lighter areas would be raised areas on the surface, normal mapping is far superior because of the 3 separate color channels. You have a lot more variation, a lot more ability to show finer detail. So that's where it's going to win out over old school bump mapping. If you have no idea what I'm talking about, don't worry about it. It's not really important that you do. The thing that is important for you to understand is that normal mapping is really the key to a lot of Unreal Engine 3's visuals. It is probably, in my humble estimation, the most important channel in this entire material, in the entire material system, for making your objects appear to have that Unreal Engine 3 feel, where it looks like they're made out of just millions and millions of polygons, even though it's actually a very simple surface. All right, so moving down from here, we have the custom lighting channel. This is really only usable. It's kind of defunct and doesn't do anything until you take your lighting model and set it down to custom. And I don't have any way to demonstrate this without having a much, much, much longer video. But you can use this as a way to create a series of material expressions which would design your own lighting model. Maybe you don't like the Phong lighting model and how it deals with light, and you want something else. Something like a cel-shaded effect for like a toon shader, or maybe an anisotropic kind of shader, which is the kind of thing you see on brushed metal. You can use your various skills at putting together material expressions and your information on mathematically how light behaves on surfaces to put together an intricate network which would eventually scale down and plug into custom lighting. Then just switch your lighting model property over to custom lighting, and there you go. You're now using your own lighting model. All right. Wow. So it's almost like I feel like I should stop and take a break, but we must press on. What I told you I was going to be doing in this video is increasing the specular value of our rock. We're going to add some sort of specularity. We are going to also make some adjustments to the normal map and make this look a little bit more realistic. And let's just start off with specularity. Right now our rocks have no specularity, so they look kind of chalky, like no light is shining off them. And what I would like to do is make them look a little bit shinier. But at the same time, as you saw earlier, if I was to create a simple constant 3 vector, and this time I did just drag it out of the material expression node. By the way, remember, you can right-click to create these, but because my menu runs off the screen, I find myself not using it very much. So let's go ahead and set this to white, which is 1, 1, and 1 for all 3 of these. By the way, just a tip, in case you've forgotten, this is true among many of the windows inside of Unreal Engine. A lot of the property windows. Don't use tab to jump from one field to the next. Use the down arrow key. Tab doesn't work. So we set all these to 1, so we have a value of white. Let's plug this into specular. And everything becomes shiny. Really shiny. This thing looks like it's not only been waxed, but it was then buffed. And then it was shined with lacquer, and just all sorts of things have been done to make this really, really glossy. And the other problem is that the moss inside is also glossy, and that's no good. If the rocks have a little bit of shine, that's fine, but I've never seen shiny moss in my entire life. So let's go ahead and delete that. We're not going to use a constant color and apply it to our entire material. What we want to do is selectively add specularity to only certain areas of the rock and not to others. To do that, we need some form of a mask. We need a texture that is black in the areas of the moss and is white or lighter. I'm not going to say white because white might be pushing a little bit, but lighter than black over in the other areas where the rocks take place. Now, we kind of already have that over here inside of our original texture sample. If we take a look at its... let me jump over here back to the generic browser. Let's double-click on the texture itself. You'll notice that even though we know there's green moss in between those rocks, in general, it's very dark. So it could be a good basis, a good place to begin. So what I'm going to do is just close this for now. Let's close this out. You can start simple. You could just take your texture sample and plug it into your specular channel. And you immediately get something that's a little bit more interesting and a lot more subtle. Our rocks appear a little bit shiny. The moss might have a little bit of shininess, so wherever that bright green appears, you're going to notice that it gets a lot more apparent. So how would we pull that down a little bit? How would we start to really choke out those darker areas of green? Well, you have a lot of different ways you could go about that. One way, and let's see how well this is going to work. We could start clamping values out. So let's bring in a clamp, and here's how this is actually an interesting little operator here. What we're going to do is plug in our texture sample into our very top input. Now, what is this? This takes our texture information and it loads it into the clamp. Now, what does a clamp do? It's going to take values and clamp them off, literally cut them off between a range that we specify. Right now, we essentially have R, G, and B values coming in between ranges of 1 and 0. We can clamp things down so that they don't go as high or don't go so low. So let's start off, and this is just kind of a real-time experiment. Let's bring in a constant. Again, I'm going to hold down the 1 key and left-click, and the 1 key and left-click, so I have 2 constants. And the first constant we're going to set to maybe, well, let's leave that at 0. So our minimum value is going to be 0. And we'll take our maximum value, and just for the time being, let's set this to maybe 0.5. Now take a look at what happened here. We did get a little bit of a change. If I unplug, you can kind of see, well, actually, okay. We didn't get much of a change.
Okay, it was close.
It was close. It's not really what I'm looking for. So here's what I'm going to do. I'm going to bring this way down to like 0.01. So we're clamping everything off, and things actually become kind of black. And that's because we're only allowing a value of ranges in between black and almost black.
Right.
Now, we could plug this into specular, and we pretty much lose our specularity, and we can start to bring up our maximum value. Let's maybe set it to 0.2. and start to increase this. But this is still kind of giving us specularity here inside of our moss. Now, what I'm doing in a roundabout way is I'm trying to show you some of these other expressions in here.
To be honest with you, that was actually working pretty good. You'll notice that the green is still about the same.
Well, I had another one I wanted to...
Okay, I just wanted to point out to them, just in case they didn't notice, that it did work really nicely.
Absolutely, but there's one more I wanted to show.
Okay.
I wanted to get their head wrapped around like a clamp, just as an example, and then I wanted to show them the power node. Now, what power is going to do is it's going to take whatever values that you have and raise them to a power. And I really wanted to bring this in because if you're completely new to working with numeric values for colors, this will blow your mind. You won't understand what's going on. Just remember that every color you see is a value between 0 and 1, and you're going to take that value and raise it to a specific power. In general, without trying to worry about the mathematics of it all, increasing the power value of a color will increase its contrast. So let's hook this up. I'm going to take my base, which is whatever our color that we're going to start with. That's going to be our texture. Let's just plug that in like so. And then we can take our exponent value, which we need a constant for this. Let's hold down the 1 key and again left click and plug this in. And so we don't really see a nice representation here inside of this. We would have to actually, if you want to, we could plug it into diffuse and show you what we get. So right now we're raising this to a power of 0, which doesn't help us much. Let's raise it to a power of 1, and now we're exactly where we started. Now let's start lifting that exponent, so we'll maybe raise this to a power of 2. Ooh, it starts to darken, but it darkens in a really interesting way. The parts that were darker get even darker than they were before. The parts that were light are still kind of staying with us a little bit better. So we're increasing that contrast value. So let's take our texture sample, and we'll plug that back into our diffuse. We can plug this into our specular, and now we've got it's a very, very subtle shine, but we're keeping it nice and dark here inside of our mossy areas. Now, what if we want our rocks to be shinier? Well, now we have to start getting clever. We need to increase the amount that we have here inside of our power without increasing what's going on over here. To do that, we can use a multiply node. We can multiply this by some value. Now, let me take my texture sample and pull it out of the way. Now, if you're already lost in the math, don't worry about it too much. You're going to have to kind of start thinking about colors in terms of numeric values. And that's not an easy thing for some people to get into. I completely understand that. But just keep in mind, for power, we've increased the contrast. With a multiply node, what we're going to do is start to increase values that are greater than 1 while taking any values that are around 0 and leaving them alone. It means it's going to be great for us because we can take the rock values and start to push them higher while leaving those grout or mossy values relatively low. So let's bring in a multiply node. I'll drag this first one out of our material expression list and alphabetical order.
Yes, it's in the M's.
Yeah, thank you.
No problem.
I was actually waiting for that. I'd also like to give myself a little more room. And what I'm going to do is hold down the Control and Alt keys and create a marquee selection. Now, that's fairly common in a lot of various parts of Unreal Ed, but if you haven't seen it here, you can use it. And now we can move both these out of the way and we get a little bit more room. I'm going to move this multiply node right in here to kind of intercept the wire. We'll plug one wire into input A. All this is doing is taking input A and multiplying it by input B. I'm going to create another constant. I have a constant over here, and because it's fast, we'll hit Control-C, Control-V. So to show you all sorts of different ways to create nodes. And let's just plug this into input B. And I'll bet you can't see it on the video, but it did actually get a little brighter here inside this window.
Oh, no, I can see it.
And we'll plug into specular, and
there it goes.
It's really subtle, but our rocks are a little bit shinier. If you don't believe me, take your constant value and drive it to something nuts, like 100. And now our rocks are almost sparkly, like they're some sort of metal. But take a look at our mossy areas. They're nowhere near as shiny. Now, in this particular case, I've overblown it.
Oh, yeah.
I've really overdone it. So you'd really want to keep this to a lower value. Let's say 3, and you can start to see some shine there, and our moss doesn't look shiny at all. So I've shown you a couple of ways to kind of go about chopping out values, kind of masking values. But here's the cool bit. We're using existing textures that are already in our material. We're taking some of that information and just chopping it out. Now, a way to push this even further is you'll notice, if you look really closely, that our specularity has a certain color to it. We're actually absorbing some of the color from the rocks. I like that. I think it works well. But if for some reason you're working on a material where you want a white value, you have some options, and let me discuss some of those with you now. There's the long option and the short option. Let me do the long option first, because that might be the first one that comes to mind. I'll give you a little bit more room just by marquee selecting and dragging back. You have a desaturation node whose only purpose is to remove color information. So you'll notice he's got an input and he has a percentage. The input isn't really labeled. So we can connect this in like so, and then we have a percentage value which just receives a constant between 0 and 100 as for how much color information you lose.
Plug the output of your multiply up into diffuse again.
Multiply into diffuse. Yes, sir.
Bing. There we go. Just so that they can get a better idea of what's taking place.
Because
it's really difficult to see on the speculator.
Actually, that's a really good point. I hadn't even thought about that. Thank you.
So now they can actually see what's happening.
So let's create a new constant. I think I can just hit Control-V because I had already copied one earlier. And let's leave this set to a value of 0. And I'll plug this into %. And then we'll take this and plug this into diffuse. And currently nothing happens because our percentage is 0, but let's push this just starting at 1, and there you go. Our color information completely disappears. And just to really drive it home, let me break our connection to specular so that now the whole thing is in black and white.
Very cool.
So if for some reason you wanted a black and white specularity, you could just do that. And there you go. And now we can go get our diffuse channel back from our original texture. So I'm sorry about my limited screen space here, guys. Let me back out so you can see the whole network. So that's one way to go about it. There is a faster way, and I accidentally created a constant clamp. Excuse me, I was holding the C key at the time. So there's a faster way to go about this. Let's kill out our desaturation node, and we'll hook our multiply back into our specularity. Remember, as we discussed earlier, that each one of these channels doesn't actually show red, green, and blue information. They show the amount of red, green, and blue information on a grayscale basis. So we could just take the red channel and plug that into the base of our power, and we immediately lose color information in our specularity. And to prove it, I can take this second little constant that we have here, and we can drive this back up to, say, 100, and now it's perfectly white.
Yep. So look at the multiply node itself.
Yeah, it's perfectly white.
And yeah.
So just as a, there you go.
Thank you. I feel better now.
I was pointing at the wrong one. See, I was distracted because we had that floating constant there. But let's go ahead and put things back down to 3. And there you go. So a lot of different ways to handle things. And I want you to be exposed to that early on. I want you to realize very early on that there are many, many, many ways to handle problems inside of your various shaders that you're going to create, inside of your materials. So we'll leave it just like this. I think this is going to work for now.
So now we've got a little bit of specularity. Now detail.
All right, so here's the deal. If we get right up onto our rock, we lose a lot of that visual, tactile detail.
Start to see the pixels almost.
Yeah, things get kind of chunky. So what I would like to do is set up some sort of a system where when we get really close to the rock, we see all sorts of little tiny cracks and crevices in it. And fortunately, UT3 comes with a series of textures specifically designed for this. So let's open those up. What I'm going to do is start off by creating a new texture sample. And notice, again, I had a texture selected at the time, so it comes in with a texture already.
In your generic browser.
Comes in by default, nothing you can do about it, but we can assign a new one in over it. Let's go ahead and show the generic browser, and I'll go to File, Open. And if we scroll down to the end of our environments, we have get all distracted for a minute. It's actually not in here. I need to back out. We come out to Textures. I've lost it.
Uh-oh. Where's it at?
Where's it at? Where I've become completely confused. It's under Detail Textures. I'm sorry, it was in Environments. I got a little turned around because I've been talking too much and I'm low on oxygen. So if we go under Environments, we have UN Detail Textures. Let's go ahead and open up this package, and we have a series of textures you can see here. And take a look at them. Open them up and sample them. I don't think that one really works.
Yeah, think about what would work really good if you were to zoom in really close.
I mean, that looks kind of cool.
It's not bad.
That's not bad. We have little tiny, I don't like that. Almost
little
looks like
parasites or something.
Yeah, like water or some sort of slide from a microscope.
No, I don't like that one.
No, I think I'm going to stick with this guy we opened up a second ago.
Okay.
So this is just a detailing texture. Let's go ahead and bring it in. So we have it selected. We'll close the generic browser, and I'll use current selection in browser, And so now everything's in place. But how do we get this applied to our current normal map? This is where things get a little tricky and where we have to start thinking about how color information is actually stored and used as numeric values. What I would like to do, and it's cool because this works mathematically and it works in English as well. I want to take this normal map and add this normal map to it. Well, great, that works. Let's go ahead and get an add node. We'll drag it into place. I'm going to take normal map number 1 and plug it into A, normal map number 2 and plug it into B, and then we're just going to plug this into normal. Now this kind of works and it kind of doesn't work. And the reason I say that is because if I plug my original in, watch our preview window very, very closely, as I let go of the mouse, we have a lot of really nice depth here. And as soon as I plug my add node in, watch the preview again, we lose a lot of depth. Suddenly it doesn't look like our normal map goes as deep as it used to. And the reason for that is that we are doubling that blue value. That blue value actually runs along the z-axis, which points directly at us, and it controls our overall amount of depth. So by increasing that, by adding blue to blue, we're killing out some depth information. Now we need to fix that. How do we go about fixing that? Well, it's actually pretty easy. What we're going to do is take our existing texture sample here for our second normal map, and we're going to multiply it by a special vector. Now, I know that sounds really scary, but I'm going to break it down for you. Let's start off simple. We'll bring in the multiply node, and by the time we're done, you're going to see what we're doing with this color information, how we're manipulating the numbers to come up with a new value, okay? We'll start off by taking our RGB value, and we'll plug it into slot A. Now, I'm going to create a constant 3 vector, which, of course, we could hold down the 3 key and left-click, but I'm going to drag it out of the material expression list, and we'll plug this into value B. Now let's set some values. I'm going to take R, which is the red channel, and we'll set this to 1 for the time being. I'm going to come down to green, which is G, and we'll set this to 1 for the time being, but I'm going to leave blue at 0. When you multiply any number by 0, what do you get?
0.
By doing this, we have, and you can already see it here inside the multiply node, we have nullified the blue channel. There is no more blue. Now we can take this and plug it into factor B for our add, and there we go. We're no longer double increasing that blue value, and we get all of our depth back. The cool thing is our normal map, as my tongue starts to stick to the roof of my mouth, our normal map now has this detail information, but it's not very detailed. What we need is to tile this and have a lot of little tiny copies of this scattered across the surface. To do that, we need a texture sample node. I'm sorry, not texture sample. We need a texture coordinate node. I read texture sample because it was there on the screen. Let's drag in a texture coordinate, like so. And what I'm going to do is plug this into the UV's input for our texture sample. And what this is going to do is change or give us access, the ability to change the number of times that this texture sample is tiled. So let's select our texture coordinate. You'll see U tiling and V tiling. That, in essence, is tiling horizontally and tiling vertically. I'm going to set them both to the same number. Let's say 15. And as soon as I do that, things change over here. You'll notice we get some streaks all along our surface. And then let's set this guy to 15 as well. And there you go. So now if we get really close to the rock, we can start seeing little tiny cracks and crevices all over it. And if you're not convinced, if I just don't see it, well, let's go ahead and just connect up our original normal map. And now let's connect our new network. High detail, low detail.
There you go.
So that's how it works. And the cool thing about this is the setup that we've created allows for a lot of flexibility because we can increase our tiling if we need our detail to get even tighter. Maybe, I wouldn't go too much higher, but let's say 20 by 20. So now we got these, very much tighter crevices. If a player got right up to a wall, they'd see these cracks and crevices. And maybe we want these cracks and crevices to be more pronounced or less pronounced. In that case, we would need to come over to this 3 vector that we've created, and we would need to change these values that we have plugged in for red and green. For example, if I set these from 1 to 0.5, we have half as much of that crackling taking place. If I push them all the way up to 2, we have twice as much. And things actually start to go a little bit overboard at that point.
Yeah.
But if you want a subtle effect, it's not a bad idea to use a fraction. So it could be like maybe 0.6. Did I get point? It doesn't look like it read my decimal point. So 0.6 and 0.6. And there we go. So we have a nice subtle detail effect taking place in our normal map. Now with that, we have done everything that I wanted to do to this material so far, save one thing. I would go ahead and end the video, but there's one last thing I want to bring up, and that is that already we're starting to create a network which could be a little bit confusing if you jumped back into it after a certain amount of time. It would be nice if we had some way to label our nodes so that we knew what they were doing. And to do this, all we really need to do is change the description property available inside of every single material expression node that you have. So
you would like to actually see a description for.
Yeah, exactly. You don't have to change it for all.
Yeah, just so there's nobody misunderstanding that.
Yeah, just make it's not like a requirement, but like for example, we have this constant that's plugged into our multiply node, and this controls how much specularity that we're allowing ourselves to have. Currently it's set to 3. If I set that to 100 like I did earlier, things get a lot shinier. So we can take the description and set this to specular amount. And there you go. The word specular amount actually appears over the node. It doesn't zoom, so as you zoom out, it stays nice and big. So in that way, you know immediately what this node is here for. Now, I'm not going to do this for all the nodes. And also, just as a side note, there are other ways to comment that we'll talk about later. But because this was already getting a little bit visually confusing, I wanted to show you a way that you can start kind of delineating what's going on inside your own network for yourself later on, or for maybe somebody else who's going to be working on this material. So let's take our description for this texture sample, and we'll call this our detail normal map. And there you go. And maybe this one will be detail amount. And that's all I'm really going to do here, but I just wanted to show you a way that you can add some labels. Now, with that, we need to apply this. So let's go ahead and click on our Apply Changes to Original Material and in the World. Give that just a second to calculate, and we'll close out the Material Editor. And things have definitely changed for us for our rocky material. It is looking quite a bit different. You'll notice a little bit of shine here. I could, if I was feeling really industrious.
Go throw a light in.
We'd create another light.
Yep, there you
and
go.
Start to move it back and forth.
Very nice.
And you can really see that shininess starting to stand out.
Mm-hmm.
And if I put the camera right down on the surface, we can see those
all the little detail.
Cracks and crevices starting to appear for us.
Let's go ahead and save our package as well. That's a good habit to get in.
Yeah, and I would forget because that's what I do. So let's go back down to Zach Materials, File, Save. And with that, we are done with this video, and you should now have a pretty solid idea of what each one of those channels do inside your material. So that's going to wrap things up for this video. Thanks a lot.